Thank you and good afternoon, everyone. I hope everybody can see me and hear me. So thank you to give us the opportunity to present this unique product in the field of VCSEL testing and metrology. So let me start by giving you a brief introduction about who we are. Instrument Systems was founded about 35 years ago in '86 and is part of the Konica Minolta group since the last 7 years. We provide testing and measurement solutions for a wide range of industries, including display manufacturing, infrared VCSEL manufacturing, and automotive sector. We're based out of Munich and with a branch in Berlin as well, where at these sites we develop and manufacture our entire product line. Apart from that sites, we have a network of distributors and calibration labs across the entire globe. From the wide range of application areas that we cater to, like display measurement and LED measurement technique, today I will be presenting you or focusing on our products in the VCSEL testing and metrology field, especially the VTC4000, the near field VCSEL testing camera. Just to start it, let me give you a quick overview of the VCSEL technology portfolio that we offer. We provide testing solutions for the comprehensive characterization and inspection of the temporal, spectral, electrical, and spatial properties of VCSEL. So you combine a high-resolution spectrometer with an integrating sphere and a photodiode, you get a fast, reliable, precise test equipment. You include the PVT, the pulsed VCSEL tester, which extends the photodiode and spectrometer configuration with a nanosecond pulse driver electronics and fast photodiode. Then it completes the package of a complete electrical, spectral, and temporal characterization. And adding to that, the camera-based systems that will then give you the solution for your spatial characterization. The good thing about all of these products is that these products can not only be used in the laboratories, but also in the production lines at the different stages of the VCSEL value chain, especially to meet those challenges associated with testing and characterization in those at those stages, especially at the wafer level. It has been known that it's a challenge, and we are ready to meet those challenges with the VTC. To just give you an idea, how does this translate into a real world application? Like of a VCSEL, if I take an example of a time of flight, you can see that we have the products that cater to all of the properties that are needed to be measured. For example, let it be the pulse, the diffusion for the beam profiling, or even at the single emitter level, which is the near field camera, the VCSEL testing camera 4000, which I will be presenting to you from now today. So, as we are aware, identifying the functionality and quality of VCSEL's array on the single emitter level is a very important task, especially in the production environments, and can be carried out This can be carried out by the VTC4000. This is a specially designed system, consists of a camera and microscope optics, and permits measuring the spatial distribution of the light from a VCSEL array with a single shot image. The information enables the analysis of each single emitter in terms of absolute power within a very short time frame, enabling stuff like defect detection even in the production. The system is optionally equipped with two things. So one comes with a fiber output and one without the fiber output and one with the fiber output with a translation stage as well. So which only moves the optical parts so that you don't have to reposition your DUT during measurements. And with the fiber optics that are attached, you can have an additional high resolution spectral radiometer, which then enables the analysis of the spectrum for each single emitter on the array. The VTC4000 allows to measure a series of images of the VCSEL array in order to get all the optical parameters of an array, such as X and Y positions, focus position, absolute power, polarization, numerical aperture, the beam waist, the M² value, and so on. So together with the spectral radiometer and the translation stage, you also have the possibility to measure the spectrum of each individual emitter, and that can be characterized including the peak and the centroid wavelength. So here you can see that you have the set of emitters, and you can, with the help of a translation stage and the high resolution spectral radiometer, you can measure the centroid wavelength, the peak wavelength, the spectrum of each single emitter. Yeah. One of the most unique features of the VTC 4000 is its capability to measure polarization corrected absolute power. I mean, we know that each emitter within an array and within itself will always show different kinds of polarization. Hence, it has become extremely important to account for it while you're measuring accurate absolute power, especially for values, determining values for laser eye safety classifications, for example. So the innovative calibration concept of the VTC 4000 is based on a flat field and a polarization correction. The polarization correction actually takes place in the form of an inline analysis of the emitted light and corrects the polarization dependency of the entire optical system. So this calibration enables absolute measurement of power and polarization properties such as angle and degree of each single emitter within the camera's field of vision in a one-shot process. And this can be very helpful to analyze and characterize, for example, polarization controlling techniques. And this unique measurement concept actually guarantees a very minimum error budget in absolute power measurements and results in a very high measurement accuracy, as currently actually offered by no other near-field VCSEL measuring systems. Of course, no hardware is complete without a software. So we have a software as well. In Lumi Suite, we offer a very robust and flexible image analysis software suitable for lab as well as production line. So we have the SDK that further empowers the VTC 4000. And to conclude, to give you some statements and to take some points to take home, the VTC 4000 in a nutshell, it's a near-field camera specially developed for ultra-fast, precise 2D analysis of VCSEL arrays, especially the wafer level in production lines. It enables polarization control characterization of all relevant parameters simultaneously for the single emitters of the array. And thanks to the unique calibration concept, 2D quality analysis is performed with unprecedented measurement accuracy. And like all of our systems at Instrument Systems, the VTC 4000 is traceably calibrated to national standards like the PTB or NIST and delivers measurements with absolute precision. So thank you to give us the opportunity to present this unique product in the field of VCSEL testing. That's my time, guys. Thank you very much. And yeah, I'm ready for questions if you guys have any.